For circuits containing two batteries or some more complex circuits, oftentimes we use Kirchhoff's rules. Okay, so we saw this with our parallel circuits, the junction rule, that the current going into a branch, the current in, split up, and it equaled the current going both ways. So the top current here will equal the bottom current. The sum of these, the top and the bottom current, will equal the current that came into it. Also, when you have a complete loop, so if you follow the current and you make a complete loop, the sum of all your potential rises, or the total voltage of the loop, is 0. So when we're going to work these problems, we need to label the current in each branch. And generally we're going to have it come out of the strongest battery, out of the positive terminal. But it doesn't really matter which way we do it. We can choose any direction and we will get a negative current. And that just means the current goes in the opposite direction. And then you're going to figure out which is it going against the circuit or is it going with the current. And then we're going to set up we're going to use the junction rule and the loop rule to get a whole bunch of equations, and then we're going to be solving systems of equations. Generally, the easier way to solve the systems of equations will be to use the matrix function on your calculator. Okay, so this one only has one loop, and each of these is a 5 ohm resistor. So that's ohms, 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 ohms. So you might want to draw this out real quick. Pause and draw this out. But we see that the 12 volt, we have a 12 volt battery here and an 8 volt battery here, but we only have one complete loop. So we're only going to use the loop rule once on this one. And since the 12 volt battery here is stronger than the 8 volt battery, we're going to have our current go from the 12 volt, and it's going to go around from the positive side of the 12 volt into the negative side of the 12 volt battery. So applying our loop rule would look like this. Okay, to get our voltages, our voltage is equal to current times resistance. So all of our voltages are going to be current times resistance, or it's going to be the voltage of the battery. Okay, so applying our loop rule, we get a positive 12 because we're going to add 12 volts due to the battery right here. And then we have a potential drop. We're going to lose some potential as we go through the 5 ohm resistor. So it's 5 ohms times the current. We don't know what that is. And then it's going to continue and it's going to go through the 4 ohm resistor. And it's going to be another potential drop, so minus 4I. And then we're going against this battery. So you see how this is the positive side and this is the negative side? So this battery isn't adding to our current, it's actually taking away from our current. So we're going to subtract the 8 volts from the battery, and then we're going to continue here and we're going to go through the 2 ohm resistor, so minus 2I, and then minus, coming back up here, minus 3I, and all of that we get back to the battery. So we've used everything that's in our circuit. All of that is going to equal 0. So the equation we have is 12 minus 5I minus 4I minus 8 minus 2I minus 3I, and that all equals 0. So combining like terms, we have the 12 and the 8. So 12 minus 8, that's 4 minus, and then we have 5, 9, 10, 11, 14I equals 0. And so then we have 4 equals 14I. And then, so dividing by 14, we get I equals, so we get our current is 0.286 amps. Now that one was fairly easy because we only had one loop, we only had one current, and so that one wasn't so bad. So here's what we did. We took our 12-volt battery, okay, it was a potential add because 12 volts is going to add to our potential, and then we subtracted the 5 ohms from the 5 ohms times the current through the first resistor, because that's a potential drop. It's going to use up some of the potential energy. And then the other 4 ohm resistor is also going to use up some of that potential energy. So we subtracted that. We were going against this battery, so we subtracted that battery out. And then V equals IR, so 2 times the current, 3 times the current, and then we're back to the battery, so that whole thing, this whole thing adds up to 0. And then we just had one variable, so we just solved for I. Okay, this circuit is a little bit more complicated because we have two batteries, and we've got one loop here, we've got another loop here, and actually we have a third loop around the outside. So it's important to be able to identify the loops. I2, we're going to say I2 is going to come out of the 80-volt battery. Okay, the problem already gave us I2, but let's say it didn't give us I2. The 80-volt battery is bigger than the 45-volt battery, so we're going to say that's going to be the most powerful one. And then it's going to go through the 1 ohm resistor, through the 20 ohm resistor. When it gets to this junction here, it has a choice of directions. So it can go this way, and there's I3, or it can go this way, and I would make I1 go the other way. But let's leave it the direction that it's drawn here, because that might give us the negative, and then we can see how that works out. So right now we kind of think the current's going to go this way, but it was labeled going this way, so we'll just go ahead. But I1 is the current only through this loop right here. Here's our node right here. So I3 goes into the node, I1 and I2 come out of the node, I2, I1, I3 goes in. So I3, our node rule is that the currents going in equal the sum of the currents going out. So I3 equals I2 plus I1. Okay, so then we're going to pick a loop. So let's pick this bottom loop. This bottom loop right here. So the bottom loop's going to be in blue. The bottom loop has I2 through the bottom part of it. I2 goes through this part. But then when we get to here, this is I3. So our loop rule, we have the 80 volts from the battery, and that's going to go through the 1 ohm resistor, so that's going to be a potential drop, 1 times I2. And then that's going to go through the 20 ohm resistor, so that's going to be another potential drop, 20 I2. And now we're going here, and we're going to go through this battery. Since it's going negative to positive, that's good. That's going with the battery because the current likes to come out of the battery. So that's good. So that's going to add to our voltage. So that's going to be plus 45 from that battery. But then the 1 ohm resistor is still going to be a potential drop. So 1, but I3 is going through that now. 1, I3, and 40 I3, because I3 is still going through both of those resistors. And then we're back to the 80 volt battery, so that all adds up to 0. Can I copy these guys now? Copy.
Every year I have trouble remembering the difference between male and female on these guys. The big black stuff is the lungs.
Okay, we have 3 unknowns, so we need 3 equations, so we need to do at least one more loop rule. So let's pick, it doesn't matter which one, but let's go ahead and we'll pick the top loop. And the top loop, we're going to go around this way because we're going to leave the battery. The current's going to leave the battery from the positive side, come in the negative side, so it makes sense to go to the left. And so our loop rule for the top one, notice I've changed colors, I often do this, is 45, okay, the battery. And then we have a potential drop across the 1 ohm resistor here. We have a potential drop. So minus 1I, and see how this is I3 now? So we're going to go 1I3. And again, we're going to go through this one minus 40I3. Okay, then now we're at I1. See, I1's going through the rest of this. So I1, so then minus 30I1, and then we come around, and we're back to the battery. We don't pass anything, so that's all going to add up to 0. So now we have 3 equations, 3 unknowns. We could do a 4th equation. Let me just show you what that would look like. Let's change colors, make it a red one. So the 4th loop, or the 4th equation, could be if we use this whole outside loop going around this way. Okay, so starting at the battery, 80, and then we're going to go through the 1 ohm resistor. I2 goes through, I2 goes this way. So minus 1I2 minus 20I2. Okay, now we're going to come up this way, and do you see how I1's actually going this way? So this isn't a potential drop. Since we're going against the current, we're actually going to add that one in. So that's 30, we're going to add 30I1. And then we're following the loop, and we are back to the battery, and that adds up to 0. Okay, transferring our equations from the previous page, these can be simplified using combining like terms. So the blue equation can become 80 minus 21I2. Well, actually, the 80 can be combined with 45. So that becomes 125 minus 21I2 minus 41I3 equals 0. And the green equation can become 45 minus 41I3 minus 30I1 equals 0. So, rearranging these so that we have I1, I2, and I3 all on one side and the numbers on the other side, the first equation becomes I1 plus I2 minus I3 equals 0. The second equation becomes 21I2 minus or plus 41I3 equals 125, and the green one becomes 30I1 plus 41I3 is equal to 45. So notice I left spaces. There's 0 I1s here and 0 I2s here. So what we're going to do now is we're going to set up our matrix, and we're going to solve this with our calculator using a matrix. So the first equation becomes 1, 1, negative 1, 0. The second equation becomes 0 because there's no I1 term. 21, 41, 125. And then the third equation becomes 30, 0, 41, 45. So this becomes a, when we put this into our calculator, this is a 3 by 4 matrix. So we're going to go ahead and put it in to our calculator. And then we're going to, once we put that into our calculator, we're going to go RF. And then the matrix name in my calculator, it's A. So I'm going to go RFA. So when we do that, our answer comes out to, our matrix answer comes out to 1, 0, 0, negative 0.858, 0, 1, 0, 2.58, and 0, 1, 1, 1.73, rounding off. So what does that mean? Because, oops, this is 0. Because we have all ones across here, that means it worked. And then this is I1, this is I2, and this is I3. So I2, coming out the bottom here, is 2.58 amps. I1 at the, or I3, let's look at I3. I3 coming out of this battery is 1.73 amps. And remember at the beginning, I said that the current probably should go this way, but our picture had it going the other way. Okay, because we got a negative value for I3 or I1, because we got a negative value for I1, since it was originally, when we set up all of our equations, we set it up going to clockwise, basically. We set it up going clockwise. That, since it's negative, that really means it's going in the opposite direction. So the original guess that it really should go counterclockwise around this loop was actually correct. So that means that I2 or I1 is actually going in this direction. This is the actual value right here. This one here is the actual value, and it should be going that direction, and it's 0.858 amps. So our answers are that we have I1 is going to the left, 0.858 amps. I2 down here at the bottom is going to the right, and it's 2.58 amps, and I3 is going to the left because it was originally correct at 1.73 amps.